Now let me show you a trick that will make a line go closer to a point. Let's say we have our linear equation, for example, 3x1 plus 4x2 minus 10. And that linear equation gives us a line, which is the points where the equation is 0, and two regions. The positive region drawn in blue, where 3x1 plus 4x2 minus 10 is positive, and the negative region drawn in red, where 3x1 plus 4x2 minus 10 is negative. So here we have our lonely misclassified point, the point 4, 5, which is a red point in the blue area. And the point says come closer. So how do we get that point to come closer to the line? Well, the idea is we're going to take the 4 and the 5 and use them to modify the equation of the line in order to get the line to move closer to the point. So here are our parameters of the line, 3, 4, and minus 10. And the coordinates of the point are 4 and 5, and let's also add a 1 here for the bias unit. So what we'll do is subtract these numbers from the parameters of the line to get 3 minus 4, 4 minus 5, and minus 10 minus 1. The new line will have parameters minus 1, and minus 11. And this line will move drastically towards the point, possibly even going over it and placing it in the correct area. Now, since we have a lot of other points, we don't want to make any drastic moves, since we may accidentally misclassify all our other points. We want the line to make a small move towards the point, and for this, we need to take small steps towards the point. So here's where we introduce the learning rate. The learning rate is a small number, for example, 0.1. And what we'll do is, instead of subtracting 4, 5, and 1 from the coordinates of the line, we'll multiply these numbers by 0.1. and then subtract them from the equation of the line. This means we'll be subtracting 0.4, 0.5, and 0.1 from the equation of the line, obtaining a new equation of 2.6x1 plus 3.5x2 minus 10.1 equals 0. This new line will actually move closer to the point. In the same way, if we have a blue point in the red area, for example, the point 1, it's a positively labeled point in the negative area. This point is also misclassified, and it says come closer. So what we do here is the same thing, except now instead of subtracting the coordinates to the parameters of the line, we add them. Again, we multiply by the learning rate in order to make small steps. So here we take the coordinates of the point 1 and put an extra 1 for the constant term. And now we multiply them by the learning rate 0.1. Now we add them to the parameters of the line, and we get a new line with equation 3.1x1 plus 4.1x2 minus 9.9. And magic, this line is closer to the point. So that's the trick we're going to use repeatedly for the perceptron algorithm.